Hello, in this presentation I will be covering the Frad term in the energy balance for ME 490 sustainable energy. In this presentation I will cover some background information on radiation, the equation/method used to calculate Frad, and why Frad is useful in our energy balance. A little review on radiation. Heat transfer through radiation takes place in form of electromagnetic waves. These waves can do one of three things when they hit a surface of a body. They can either be absorbed, reflected, or transmitted. Radiation emitted by a body is due to thermal agitation of its molecules. Radiation heat transfer can be described by a black body. A black body is a body that absorbs all radiation that hits its surface. Actual black bodies do not exist in real life. Instead, a black body is a hypothetical body. All black bodies heated to a given temperature emit thermal radiation. This radiation is known as Qrad. This value can be divided by Q sol to then give the fraction lost due to radiation. This then gives us our equation. The radiation energy per unit time from a black body is proportional to the fourth power of the absolute temperature and can be expressed from the Stefan-Boltzmann law as Frad equals Qrad over Q sol. This then equals sigma T to the fourth over Ci, where sigma is the Stefan-Boltzmann constant, which is 5.67 times 10 to the negative 8 watts per meter squared Kelvin to the fourth. T is temperature in Kelvin. C is the concentration ratio in number of suns, and I is the direct normal irradiance in watts per meter squared. The Frad value is a unitless quantity as it is a fraction of the radiation lost. Why is it useful? Qrad is useful as it is the component of the Frad calculation. This is our fraction lost to radiation in our receiver efficiency calculation. As seen on the screen, the receiver efficiency is 1 minus Frad. Therefore, we need to know Qrad to calculate Frad, which will give us the receiver efficiency eventually. In this plot, I assume that the direct normal irradiance I was equal to 1,000 watt per meter squared, and I plotted Frad versus temperature for a concentration ratio of 1,000 suns and 3,000 suns. As seen in the figure, as the temperature increases, Frad also increases in an exponential fashion. As the concentration ratio goes up, the curve will slowly start to fall underneath each curve as the concentration ratio is increased.